My name is Abhiram Srikant Pandey and I am currently studying in third year CSE in Sri Sant Gajanan Maharaj College of Engineering, Shegaon. I am making this video to explain the concepts of disk-based file system. In this video, I will cover only the important types of disk-based file system. Now, we will see the contents of our video. What is file system? What is disk-based file system? Types of disk-based file system, Unix file system, universal disk format file system. Now, firstly, we will see what actually file system is. I have given brief and necessary information about the file system rather than going too deep in it, which will only prolong the video. File system. A file system is used to control how data is stored and retrieved. Without a file system, information placed in a storage device medium would be one large body of data with no way to tell one piece where the information starts or ends. By separating the data into pieces and then naming each pieces and then taking its name from the way paper-based information systems are named. Each group of data called file. The structure and logic groups used to manage group of information and their name is called a file system. Now we will see the topic on which we will mainly concentrate in our video, that is disk-based file system and its different types. In computing, disk-based file systems are common of such devices. As magnetic disks are the most common of such devices, most disk file systems are designed to perform too well in spite of sick latencies inherent in such media. Disk file system is a file system designed for the storage of files on a storage device. To explain it in simple words, disk-based file systems are stored on a physical media such as hard disk, CD-ROMs, and diskettes. Disk-based file systems can be written in different formats, some of which are listed below. UFS, Unix file system, UDF, Universal Disk Format File System, ZFS. Now we will see the UFS, that is Unix file system. In this topic, I will tell you about the basic information about the UFS and how it works, and also I will try to explain the concept of directory in the Unix, that is directory file structure of Unix. I have included this video because it is the most important part in the UFS and it tells us about how and where the data is stored in the UFS. So let's begin with the UFS. UFS stands for Unix file system. In Unix, an operating file system inspired by it, the file system is considered a central component of the operating system. The file system appears as one rooted tree of directories instead of addressing separate volumes such as disk partitions, removable media, and network shares as separate trees. Such volumes can be mounted on a directory, causing the volumes file system tree to appear as the directory in the larger tree. The root of the tree is denoted by a slash followed by a dot. Unique directories do not contain files. Instead, they contain the names of files paired with references to so-called inodes, which in turn contain both the file and its metadata. The original Unix file system supported three types of files: ordinary files, directories, and the special files. Directory file structure of Unix. Unix uses a hierarchical file stream structure, much like an upside down tree, with root at the base of the tree and all other directories spreading from there. A Unix file system is a collection of files and directories that has the following properties. It has a root directory that contains other files and directories. Each file or directory is uniquely identified by its name, the directory in which it resides, and a unique identifier typically called an inode. By convention, the root directory has an inode number of 2 and the lost plus found directory has an inode number of 3. Inode numbers 0 and 1 are not used. File inode numbers can be spun by specifying I option to the is command. Now, what is lost plus found directory? It is a directory in which data which is lost or deleted is stored here. It resembles to the recycle bin which we generally use in our PC or Windows. It is self-contained. There are no dependencies on one file system on another. Now we will discuss the final topic in our video, that is the UDF file system. I have concentrated mainly on this topic because it is one of the most used file system. UDF file system has its own characteristics which we will discuss further in our video. UDF file system. It stands for Universal Disk Format File System. Universal Disk Format is a CD-ROM and a DVD file system standard developed as a means of ensuring consistency among the data written to various optical media. UDF is required for DVD-ROMs and is used by DVD to contain MPEG audio or video streams. Originally developed as a replacement for the file system specification in the original CD-ROM standard ISO 9660, which is an ISO standard. UDF is used by CDR and CDRW in a process called packet writing that makes CD writing more efficient in terms of time and disk space required. Normally, authoring software, it is a program that has pre-programmed elements for the development of interactive multimedia software. Will master a UDF file system in a batch process and write it to the optical media in a single pass. But when packet writing to rewritable media such as CD rewritable, UDF allows files to be created, deleted and changed on disk just as general purpose file system would on removable media like floppy disk and flash drives. This is also possible on write-once media such as CDR, but in that case the space occupied by the deleted files cannot be reclaimed and instead becomes inaccessible. Now, explaining it in simple words, UDF is a file system which will generally use to store data on the various types of disk format such as CDR, CDRW. So, the learning the UDF file system tells us about the way in which the data is stored. Now, we will discuss the file system variations of the UDF. These are the variations in which different types of disk formats are used. By learning this topic, we will understand how different types of format such as CDR, CDRW and DVD are stored in the UDF file system. The UDF standard defines three types of file system variation called builds. These are plain, random read or write access. This is the original format supported in all UDF revisions. Virtual allocation table, that is VAT, incremental writing, used specifically for writing to CDR and write-once media. Spared, limited random write access, used specifically for writing to CDRW and DVD-RW media. Plain bill. Introduced in the first version of the standard, this format can be used on any type of disk that allows random read or write access such as hard disk, DVD rewritable and DVD RAM media. Similarly to other common file system formats such as FAT, directory entries point directly to the block or sector numbers of their file contents. In writing to such a disk in this format, any physical block on the disk may be chosen for allocation of new or updated file. Since this is a basic format, practically any operating system or file format driver claiming support for UDF should able to read this format. WAD build. Write-once media such as DVD-R and CDR have limitations when being written to, in that each physical block can only return to once and the writing must happen incrementally. Thus, the plain build of UDF can only be written to CDRs by pre-mastering the data and then writing all the data in one piece to the media. To enable a CDR to be virtually like a hard disk whereby the user can add and modify files on CDR at will, so-called drive letter access on Windows. OSTA added the VAT build to the UDF standard in its revision 1.5. The VAT is an additional structure on the disk that allows packet writing, that is remapping physical blocks when files or other data on the disk are modified or deleted. For write-once media, the entire disk is virtualized, making the write-once nature transparent for the user. The disk can be treated the same way as one would treat the rewritable disk. The write-once nature of a CDR or DVD-R media means that when a file is deleted on the disk, the file's data still remains on the disk. It does not appear in the directory anymore, but it still occupies the original space where it was stored. Eventually, after using this scheme for some time, the disk will be full as free space cannot be recovered by deleting files. Special tools can be used to access the previous state of the disk, making recovery possible. Spared build. Rewritable media such as DVD rewritable and CD rewritable have fewer limitations than DVD-R and CDR media. The sectors can be written at random, though in packets at a time. These media can be erased entirely at any time, making the disk blank again, ready for writing a new UDF or other file system on it. However, sectors of RW may wear out after a while, meaning that their data becomes unreliable through having been written too often. The plain and wet build of the UDF format can be used on rewritable media with some limitations. If plain build is used on a rewritable media, the file system level modification of the data must not be allowed, as this would quickly wear out often use sectors on the disk. which would go unnoticed and lead to the data loss. To allow modification of file on the disk, rewritable disk can be used like RMedia using the VAT build. This ensures that all blocks get written only once, that is successively, ensuring that there are no blocks that get written more often than others. This way, a rewritable disk can be erased and reused many times before it should become unreliable. However, it will eventually become unreliable with no easy way of detecting it. The above diagram helps us to understand how files are transferred in the UDF file system. The above diagram is of non-bridge UDF file system. By using the word non-bridge, I mean to say that the file which are being transferred are not linked to each other. The arrows show the in which the way files are transferred. As we can see in the image, two UDF files are being added separately without interfering each other. This is one of the main features of the file system. I have included some MCQ based on the topics, and please try to solve them. So I would like to end my video here, and I hope that you have enjoyed as well as learned some important topics in my video. I have tried to explain the concepts of disk-based file system the best possible way I can. But still, if you have any queries or questions, you can freely drop them in the comment box. I would try to answer them the best way I can. And a special thanks for watching this video. If any suggestions are there, please suggest them in comment box. They are always welcome. Thank you.